This is one of my favorite examples about how mathematical induction might show up in a real analysis class. So in this example, we have a sequence, and if we write out some of the terms of the sequence, it's pretty clear that they're converging to the number 2. Now, to actually prove that is a little bit difficult, and the easiest way to do it is maybe to use something called the monotone convergence theorem that hopefully we'll talk about in a later video. But to use that theorem, we would have to show that this sequence is bounded above and increasing. And that is something that we can prove using mathematical induction. And so we've specified our statement P and below. And I like this example because this is an example of a statement that has two different parts. I've color-coded them green and blue, and you'll see that later on in the proof. And we can do both of them at the same time. And in more complicated proofs, sometimes you have to use both of them as they play off of each other, which is pretty exciting. Verifying the base case is pretty straightforward. We just have to check that 1 is less than 2, and also that the first term, which is 1, is less than the second term, which is the square root of 3. So now, to do the inductive step, we're going to assume that the statement in the yellow box is true for some integer n, and so we're assuming both of those statements. And then we're going to show that the next statement will be true. Now, this may be a good place to pause the video and think about what's going on here, because sometimes it can feel like these proofs are written backwards from what you might be used to. But here, I'm just showing that if we add 2 to both sides and then take the square root, then we very naturally get the expression we're looking for, and you can see that's highlighted here in yellow, where we're using the definition of our sequence. And so the next part of the proof is exactly analogous. Now, instead of the green part, we're working with the blue part. And here we just have to do a very similar thing. And we see that being less than 2, once we add 2, that becomes a 4. And then once we take the square root, we get exactly the statement using that same information in the yellow boxes as before.